Hello guys, welcome back. In the last video we discussed about keywords and identifiers in C. Now in this video it is time that we now try and understand the notion of data types and sizes in C. So first of all let us take a look at data types. So data types means, see, the name itself suggests. The first part says data, second part says types. That means the type of data. So in the last video we had discussed that, if you remember the example that we had taken in the last video, the example of calculating the sum of two variables and storing it into a third variable. In that example, obviously our var1 and var2, both of them have had certain type. That means we had actually taken them to be of integer types. But then if you want, you can also change it to some decimal value type, say float or double, or you can keep it as it is. So that is what that is data type. See, over there we had taken it to be an integer. So in C programming, what happens is, whatever variable you take, you must specify that what is the kind of that variable or what is the type of variable. For example, if you want to store your name, say your name is, say, suppose Rahul. So if you want to store Rahul into some variable, then you must obviously take it to be a type of character, because that name, anyone's name, is not, it does not obviously contain integers. It contains only letters from the English alphabet A to Z. So obviously we'll take a character in that case because we want to store only name. Next, if you want to store the result of the operation 8 divided by 5, then obviously it is not a perfectly a whole number. It has some decimal value. So if you store it inside some integer, then the decimal value that the quotient contains will be eliminated. So that's why, in order to avoid such circumstances, we use the float data type, float or double. Both do the same thing, just the difference is that float has lower precision and double has a higher precision. So that was about data types in C. Now according to the definition, data types in C refer to an extensive system which is used for declaring variables or functions of different types. The type of a variable determines how much space it occupies in storage and how the bit pattern stored is interpreted. Yes, this is one important thing. The type of the variable determines how much space does a variable occupy in storage. Obviously, when we are declaring some variable, then that variable is not just floating around in the air. It is obviously stored somewhere. And what is that somewhere? That somewhere is nothing but our hard disk itself. So hard disk or maybe RAM, okay, depending upon what's the use of that variable. So that means your variable is occupying some space in the memory, be it 4 bytes or be it 4 kilobytes. That is not important. What is important is to understand that whatever variables we declare, they always occupy some space in the memory. So that is why if we changing the type of the variable or changing the data type of a variable might lead to a change in the memory size that is acquired by that variable. Next we have the types. These data types can be classified into primitive or basic, and the second one is derived data type. So some primitive data type we had seen in the last video also, for example void, int. Other than that, we have some more basic or primitive data types. These are like a float, then we have a character, we have double, etc, etc. And next is the notion of derived data types. Derived data types, the name itself says that they have been derived from somewhere. They do not exist on their own. Some primitive basic data types have been taken, and then the basic data types have been modified in such a manner that the newer data types can serve as, the newer whatever the modified version is, that can serve as a data type. And such data types are known as derived data types. For example, void, int, float, char, etc. are the primitive basic primitive or basic data types, and arrays, structures, classes, all these things are example of derived data types. All these whatever I mentioned, that is arrays, class, structure, unions, etc., these things we shall study as we move on with our course. Now obviously, yeah, in the last video I had written something called void main. So what the void keyword means: the void keyword or void type is nothing but a type which signifies null. That means it does not return anything. So for a function whose return type is void, that function does not return anything to anyone. Once the execution of that function is over, it's done. It is not going to wait to return something. And hence in such scenarios we use void types. Now let us take an example, or let us take a look at this chart over here. This chart shows three columns. The first column contains the type of the variable, the second one contains the storage size, and the third one contains the range of values. So our character variable or character data type takes the storage space of only 1 bytes, and obviously its range is from -128 to 127 if you consider the negative as well as the positive scale. Otherwise, if you consider only the positive scale, then its value range is 0 to 255. Now unsigned char. This unsigned char means whatever be the value, we will not have a minus before the value. That means for unsigned char, the storage size remains the same, that is 1 byte, but the value range changes from 0 to 255. Okay. Now the next one is signed char. For signed char means there will be some sign, maybe a minus, or for plus we obviously do not specify anything. So signed char also occupies 1 byte in the storage, but its value range is pretty less. It is -128 to 127. Similarly, we have int occupies 2 to 4 bytes of space depending upon the architecture of the computer. That is a depends upon 32-bit or 64-bit architecture. If it is a 32-bit architecture, then integer will occupy 2 byte storage. Otherwise, it will occupy 4 byte storage in case of a 64-bit computer architecture. Next, we have unsigned int. This one is also same as unsigned char. In case of unsigned char, we did not have any negative or positive. Similarly, in unsigned int also we will not have any negative or positive. It will just be the positive values. So other than int, we have short, we have unsigned short, we have long, and so on. Now let us see this. Yeah, if you want to calculate the size of some type, then for that you can use an operator, which is the size of operator. This operator returns to you the size of the variable that you specify, or size of the type that you want to find. Other than that, there is a header file called float.h. This file has few macros that allow you to see the range of values that are supported by the float data type. We will study about macros and details later on, but over here what is said is there is a header file named float.h, and this float.h header file contains few macros or few classifiers which can return the minimum and maximum value of that particular data type. For example, flt_min, flt_max, both of them are a part of this float.h, and these are macros. So flt_min returns the minimum float value, and flt_max returns the maximum float value that is possible. So these are the three basic types actually we have in order to, if we want to store some decimal values, then we have these three basic types. So the first type is float, and its storage size is 4 bytes of memory. The value range is already given over here. It is 1.25 to the 1.2 into 10 to the power minus 38 to 3.4 10 to the power 38. So that is the range of the values that float supports, and its precision is 6 decimal places. On the other hand, the double type, the second one, the double type has a storage size of 8 bytes, and this is its value range. and its precision is very nice or very good as compared to float. It has a precision of 15 decimal places. And next we have the precision of 19 decimal places, which corresponds to long double, and its storage size is 10 bytes, and also its value range is given over here. So that is all about this video. Let us take a look at a small example. Over here I will write, say, printf maybe say, if you want to write size of something, comma, size of int. So over here we are saying that we want to compute the size of an integer variable. So let us see if it runs well. Yes, so over here we can see the size of integer is 4. So similarly we can have the size of anything that we want. For example, size of float. Then say we have this size of long, size of char. And in order to be able to understand what is getting printed, let us put new line character over here. So this will help us to introduce new line everywhere. Further, let us write like this: int float long, then we have char, and so on and so forth. We can also have double, we can have long double, we can have long int. So it is basically up to us in what is our requirement and in what scenario are we going to use the data types. So say we have a double over here, so size of double. Say if we have a long double, then here we'll write long double. So these things will return to us the size of all these operators. So let us see, if there is no error, it should compile perfectly. Yes, see, the size of integer is 4 bytes, float is 4, long 4, char 1, double 8, long double 16, and so on and so forth. So this size of operator is a very important operator as of now, because this will return to us whatever is the size of this particular data type that you have specified inside the parenthesis of size of. Now later on when we will discuss function, you might get confused that the size of the syntax of writing this thing is similar to a function, but the thing is that it is actually an operator and not a function. So this is an important difference which you should always know. So that is all for this video. Thank you.